Okay, and we are live. Hello, 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 everyone, and welcome to this ibm.codesf event. This is part one in a series of blockchain-themed events that'll be kicking off today. The next event series is going to happen next Tuesday, and then every Tuesday after that until August 7th. For those of you who are new to ibm.codesf, we're actually a team of developer advocates here in the Bay Area from IBM. And we host in-person and online meetups, lunch and learns, workshops, and other really exciting events so you can meet cool subject matter experts and learn about cutting-edge open source technologies. So, just a few community guidelines before we start. Let's keep the chat over here relevant to today's topic. And if you have any questions, please post them in the Ask a Question section here at the bottom of the screen. And upvote any questions you'd like to have answered by the speaker at the end of the session. So, without further ado, today we have Lennart Frantzell. He's an ibm.codesf developer advocate with us, and he'll be presenting on Hyperledger concepts, architecture, and use cases. So please take it away, Lennart.
Thank you, Maya. And welcome everyone to this talk. And the first question we want to ask ourselves is, where do we start? And this chart will show you where we start. We want to go back in time a decade, 10 years, till October 2008, when somebody named Satoshi Nakamoto published a paper on the web called Bitcoin, a peer-to-peer electronic cash system. And that came to change the world, and is still reverberating 10 years later. What he was trying to do is to address a key problem in electronic commerce. He wanted to be able to send electronic cash, peer-to-peer, to anyone in the world. And he wanted to be able to do that without going through a financial institution. So this was the problem he had. And he had a few things already ready for him to use, namely digital signatures. So that was part of the solution. But the main benefits would be lost if he still needed a bank, a trusted third party, to prevent double spending. And double spending is where I have a digital currency that I can spend for different things again and again and again, and so that I never run out of the digital currency. And so what he did was he proposed a solution to the double spending problem using a peer-to-peer network. And the people here on this call today, if you can go to https://bitcoin.org/bitcoin.pdf later today or tomorrow, and read through this paper. That's your task, because without having read through this paper, it's going to be very difficult to understand what peer-to-peer electronic cash systems really are all about and what it was that Satoshi Nakamoto wanted to solve. So blockchain. There are two versions of blockchain, and it's important for us to understand that. One is the one that deals with cryptocurrencies, tokens, ICOs, initial coin offerings, and blockchain. That's on the left. On the right, we have another blockchain that deals exclusively with business assets. And it's the rightmost blockchain we will be talking about today, which is different from the left one, although the two are quite similar. There still are important differences. And what we will be talking about today is Hyperledger, a version or dialect, if you will, of blockchain that is an open source collaborative effort across the industry. It's hosted by the Linux Foundation, and that's important because the Linux Foundation is one of the major actors in the open source world today. It's a very, very important foundation. And they are focusing on finance, banking, IoT, supply chain, healthcare, manufacturing, government, technology, and many more areas. So blockchain solutions for those areas by Hyperledger. So then what does Hyperledger provide? Well, if we look at the world the way it has been up until recently, we had something called a ledger, a business ledger that you used when you traded, where you could enter the amount of money you made, the amount of money you spent, and those ledgers have been with us since the Renaissance. So here we see an example of 6 businesses working together, trading together on 6 ledgers. This works nicely in the old world where things are moving slowly, but in the digital world, this is not viable, actually, because you have to keep the ledgers in sync, and they very quickly get out of sync. So this is an inefficient, expensive, and vulnerable way to do business. And that is what Satoshi Nakamoto wanted to avoid and improve upon. And what he did was something very important. He created this shared, replicated, permissioned ledger. And let's go through this now slowly. We have 6 participants, all trading together. There is one ledger and one ledger only, not multiple ones, one ledger only. Each one of these businesses have a copy of the ledger running on their business systems. So there are 6 copies of this ledger, all identical. So in order to trade on this with this system, you have to be permissioned. In other words, you have to identify yourself, and you have to be able to know who you are dealing with. The system comes with something called consensus. And consensus is where a majority of the members have to agree before any data is put on this ledger. You cannot do it anonymously. Consensus is a key system here, part of the blockchain system. Provenance, we will talk about more in a second. It's immutable. If you put data on this ledger, it stays on the ledger. You cannot erase it, you cannot modify it, you can add updates to it, but you cannot erase it and modify it. And finality, what is there stays there on the ledger. At the same time, we have something down on the left-hand side of the screen. No central third-party mediator is necessary. No reconciliation is needed. It is much, much simpler system than the previous systems we've seen in the history of the world. This is the way the modern world works with the blockchain system. Here we have some facets of distributed shared ledgers. The network nodes on the system both generate their own data and verify data generated by others. This makes the system very secure. It contains historical records of verified transactions that are easily auditable, another important point. And we have something called distributed consensus that we'll talk about more in a second. There is no central repository. Each node stores identical copies of the ledger, and that's all they do. It is resilient, and it is very difficult to break into. So this again is the distributed shared ledger. Then we have something else that people are not always understand. They don't always understand. We have permissioned and permissionless systems. We have public and private systems. So here we have a permissionless public blockchain down on the left, Bitcoin and Ethereum, you've probably heard of those. Then we have permissionless private, public polls, where we can vote, for instance, but where you cannot see, anybody cannot see how I voted. You cannot log into that system. You here to see how I voted. That's is between me and the system itself, so to speak. Permissioned public systems is like university degrees. You can see which university degree I have, but you cannot go in and add your own university degree. And medical records. Only I and the doctors can see it and put data in there. So this is important. It takes a while to figure out what the real differences here are, but there are different types of blockchains this way: permissionless, public, and private. And when you begin to work in this world, it's important to understand what system you are going to create, because they will behave quite differently. Now the question comes that I'm certain you are asking yourself, okay, you're talking about all these different things. Why don't we just use a database? Why don't we just continue the way we have for say 200, not 200 years, but 40 years, and use databases? You use IBM's DB2. And the reason is traditional databases are centralized. We need to trust the administrator, and they are not immutable typically. You update, you do a CRUD operation, you update the data in the database, and the old one is gone. So databases in the traditional way are not the solution for the blockchain. Therefore, the blockchain is not using these databases. Then we come to the consensus algorithm. A majority of the people or the actors have to agree to put new data on the system, and there are different consensus algorithms. the interesting thing here is that this is an area where lots of people are being very innovative in creating new consensus algorithms. The point I want to make here is that there are pros and cons of every consensus algorithm. There is no one that is better than anybody else. So when you begin to study and learn blockchain, remember that there is no such thing as one algorithm that is better than anybody else, any other algorithm. They all have pluses and minuses, pros and cons. And that's something you have to learn to investigate and see which one fits your system best. So here we have a consensus situation. We have 4 nodes on the left and 4 nodes on the right. Going into this, we have the value ABC on 2 nodes, the value DEF on 1 node, and then JKL, which is an outlier on the 4th node. Now we're going to crank the consensus algorithm, and when we have cranked through that, you see we have 3 nodes with ABC, which is going to be the new value, and 1 JKL, which is the outlier. And this is how the consensus algorithm works. You crank it through, and you try to get the nodes to show the same value. If one node is totally out of whack, you simply ignore that node and go with the other ones instead. So this is a high-level view of consensus. And again, consensus is a very important part of the blockchain. Hyperledger architecture. This is not something you have to go through in detail to learn when you begin to work with the system, but it just shows the major objects in the system. We have something called membership. Remember, you have to identify yourself and be admitted into this blockchain. And it says that no single point of failure and no single point of truth, which is part of the system. Then we have an SDK, and you have an application as a member. You run the application, go through the SDK, and you communicate with the peers. We have endorser peers, committer peers. And then we have the ledger. We have events that are generated, and we have Chaincode, which is the same as smart contracts, so very similar to smart contracts. When you write code in Hyperledger, you write Chaincode, nothing else. And then we have the orderer on the right, which orders the transactions that come in and puts them on the blockchain. So these are the major moving parts. And again, as a developer, you don't have to really understand these in any detail. But as you progress and learn more and more, this is the central architecture that you need to understand at some detail. Then we come to a question that I get very frequently, and we might just as well get it out of the way. What about Hyperledger performance? We hear horror stories about it only being able to address a few transactions per second. But as you can see here, we are doing more than 3,500 transactions per second with latency less than 1 second. So there is no issue here with performance, and performance is also improving as this system is growing very rapidly. Okay, Hyperledger applications. What does a Hyperledger application look like? And what can we learn from them? So here is an iconic application. This is the Ceverledger application. You may have heard of it, actually. If you're into diamonds, and who isn't, then it is important to know that the diamond has not been faked, and that it is the real diamond, and that its provenance goes back all the way till when it was dug up from South Africa, and from a South African mine, for instance. So we can track the provenance here, track diamonds across supply chain from mine to retail. And we do it by storing digital certificates with supporting material on the blockchain. This, again, is a very typical application for blockchain. The provenance problem, how can I prove that this has not been tampered with? Now we might change from diamonds to food. And here we have food safety. You see all the stores, Walmart, Dole, Nestle, Tyson, Driscoll, you recognize probably all of them. And now we are no longer interested in diamonds, but in food safety. Can we make certain that the food comes from the farm that it says it comes from and that nobody has tampered with it? And this, again, is just another variation of the diamond application, the food safety application, all running on blockchain. So you can see here that we can go from different applications using the same architecture pattern, all dealing with provenance. So if you have a question where you want to solve a provenance issue, you know that blockchain is a perfect application for that. Then we have something else here that is very interesting, which is global financing. This is something that IBM has written to prove that we can eat our own dog food. This application was actually written in September 2016, quite a while ago, and it helps us to dispute resolutions, where we have, again, multiple systems trying to talk to each other, multiple ledgers, and especially where there are challenges to what the ledgers contains. And as you can see here, we have dispute resolution time has been reduced by 75%. We are releasing working capital of $100 million. This is big, and it's big for IBM, and it shows how blockchain can solve problems quite easily if you apply it in the right way. A few more applications here that are quite new, Hyperledger adoption here. Change Healthcare's intelligent healthcare network deploys enterprise scale blockchain powered by Hyperledger in the healthcare business. Very, very big and very important for blockchain. And then an intriguing application from Illinois. The state of Illinois has used the blockchain pilot to digitize birth certificates. There again is provenance. Does this baby have the right provenance, so to speak? And you can show that on the blockchain. And since you cannot change the data in the blockchain, once the baby is on the blockchain, it stays on the blockchain. No way to change that. All right, if you have followed me so far, and I know I'm throwing a lot of things at you here, a lot of details, how do we get started working with Hyperledger? And this is actually easier than you would think. We have blockchain use cases on the IBM website you see here, ibm.com, blockchain use cases. I would start here and go through these use cases one by one to see if you find one that fits your needs. Because very many people I talk to simply say, we have something we want to do with blockchain. Tell me what we can do with it. And I tell them that that's the wrong way forward. You want to have a problem that is well-defined, and then you want to match it against blockchain and say, is this really for blockchain? Maybe you can use the old-fashioned technology. Maybe that's just as well. So you want to be careful that you really have a blockchain use case that fits your problem, business problem. And if you don't have that, then you should be a little bit careful. So here's what you will be looking for. A business problem to be solved, obviously, that cannot be solved with old-fashioned technologies. An identifiable business network. This is the key thing. If you can't identify a business network with participants, assets, and transactions, then you should stay away from blockchain. This is very important. Participants, assets, and transactions. And then the need for trust. Consensus, immutability, finality, and provenance. And provenance is a very easy thing to find. I will give you another example of a provenance use case that I'm interested in. I happen to be interested in the airline industry. And in the airline industry, you have the airlines, you have the aircraft with tens of thousands of parts for each aircraft. The ability to trace the provenance of each of those parts is important to the security of the airlines. If I can show, for instance, that this engine comes from a certain manufacturer, it has been serviced so many times in these places, that will help me to make certain that the aircraft is going to be safe to fly. This is very big in the aircraft industry, and again, it has deals with provenance, finality, and immutability. So this is a good way to look at your business problem to see if that is something that you can use blockchain for or not, as the case may be. Then we come to another important chart here. There are different types of people working with blockchain. We wear different hats. For instance, we have the blockchain architect, which is the one who designs the system, who raises the questions that I try to raise here today, and who calls the shots, as it were, for his team. Then we have the blockchain developer. The blockchain developer writes code for the blockchain application. He can ignore the design questions, the business questions, and just focus on writing the code. And the code he writes is Chaincode, and we'll show you that in a second. Then we have the blockchain network operator. The network operator operates the actual blockchain network. He or she does something totally different from the developer and has different skills. So you can decide here between architect, developer, and operator. And then we also have the membership services over on the right with another administrator. And then we have a regulator who is not part of this company, but maybe some regulator for healthcare or something else. So there are a number of actors in a blockchain solution, and it's important to understand what they are. And to get started, you can probably wear many of these hats yourself. But on the other hand, at some point, you need to separate these out and give them to different people. All right, we're going to write an application in Hyperledger. How do we do it? Well, here is some good news. We have something called a Hyperledger Composer, which is a really nice tool running on the web. It is all free to use. You can actually click on the link there now if you want to take a look at it. And it allows you to write chain code in a very nice and very high level way. People who use this, me included, love this tool. And it is one reason for using Hyperledger, because the tool is so nice and so quick to learn that you can become productive in a matter of hours, if not even shorter than that. Chain code and smart contracts. So chain code is the code you're going to write. And you wonder, so what is a chain code and what is smart contract? Well, think of them as store procedures. If you know about the old-fashioned databases, you know what store procedures are. It's code that you tie to the database that execute into the database. And chain code is something that is executed here the same way in Hyperledger. That's all you have to write. And since you can use this very nice tool to write it in, it's going to be a real pleasure for you to begin to write this chain code. And you can be productive, as I said, very, very quickly. So let's take a look at the Hyperledger Composer playground now. Here we have the screen. And you can see here then we have on the left, we have a number of files, the about file, the model file, which is where we will create the model of the business network we are going to create. And it's called a CTO file. And as you can see on the right-hand side here, the CTO file will contain participants, assets, transactions, and events. And again, if you don't have that in your solution, then blockchain may not be the thing for you. But this is how you start, by identifying, so what are the participants, what are the assets they want to trade, what transactions do they want to go through, and what events will they emit. And then going back to the left again, we see the script file called samples.js. So the model file creates the static model of your network. The script file creates how they interact with the other parts of the model. And then we have the access controls. Who can see what data in this network? And that's another very important part. So the model file, the script file, and the access control file, and then the participants, the assets, and the transactions, and the events. That's the sum total of your application, and that you can get started on very quickly. So we have the Hyperledger Composer, which generates a WAR file or something similar to a WAR file called a BNA file. And then the Hyperledger Fabric, where we install this thing on, the BNA file on, and then we run. So Composer, BNA file, and Fabric. Those are the three components. And again, the Composer is the development tool, BNA file is the application we've written, and we install it on the Hyperledger Fabric. So the Fabric is the runtime, if you will. It's the internet for Hyperledger. It has open governance. Anybody can join, and I urge you to do that. It is built for the enterprise. It has high performance, confidentiality, of course, and modularity and flexibility. It is a very nice environment. And the very best news of all, this is the URL you want to go to, the hyperledgerfabric.readthedocs.io. This is superb documentation for the Hyperledger Fabric. I cannot say enough good things about it. Everything you need to know is there. It's fun to read. You can't do anything better than spend your time reading this documentation. It is written by people for people. And again, I can not say enough give enough accolades for this documentation. It really is good. What does the Hyperledger Fabric look like in overview? Well, here is the way it looks like. We have membership services. We have blockchain, we have transactions in Chaincode, and then we have blockchain services, consensus manager, distributed ledger, P2P protocol, and ledger storage. And these are plug and play. You can rip one out and put another one into its place. And that's what people do. There's a lots of innovation going on here, where people say that I can write a better consensus algorithm than you can, maybe. And then you can play it, you can try it out here, and you can run it, and you can get people to begin to use your consensus manager rather than the one that is already there. This is a very, very nice architecture and interesting to get started to learn. So getting started with Hyperledger Fabric, develop your first network as a network administrator. You remember we mentioned that. And this is quite straightforward. If you take more than an hour to do this on your laptop, you probably are thinking of other things. This is very straightforward. It is something you can do this afternoon quite easily. Deploy your first application as an application developer, also very, very straightforward to do. So you can be up and running here with a network and an application in, say, 2 hours easily. And that's a good way to spend an afternoon. Now we come here to something that is very important as well. So now we have worked on our laptops. We have created an application. And then what do we do with it? Well, we want to sell it if we are a startup company, and we want to sell it to an enterprise company. So to write an enterprise Hyperledger application, we want to go to the cloud. And this is something we're going to do in the fourth session of this work here. And we will do it by launching it in the IBM cloud. There are other clouds you can use, but this cloud is one of the ones that I have experience with. And if you don't know how to do this, it's easier than you can possibly imagine. It is a very nice environment, like all cloud environments. And then you are running in an enterprise-grade environment. And you can get customers who are really large corporate customers to use your application that you began by creating on a small laptop. And that, I think, is about what I have for this talk. And back over to Maya.
Lovely. Thank you so much, Lennart. So let's go over some of the questions. I think we have 8 questions in the Ask a Question section. And thank you to those of you who have been answering the questions in the chat section. We very much appreciate that. So the first question, Lennart, is what language is the ledger written in?
If you use JavaScript, it's written in Golang, and you use JavaScript, and you can use Java as well, and the other languages are coming to write the Chaincode.
Awesome. And then the next answer is Hyperledger a framework?
Yes, it is a framework. It's a good way of putting it, yes.
Awesome. And Max answered a little bit more in the comments section if you want to check that out, Ambrose. Okay. The next question is, cryptocurrency requires intensive CPU to process. Since Hyperledger is the underneath technology, will Hyperledger have the same issue?
No, it will not. And exactly why that is, we can talk about separately, but Hyperledger can support very large applications, and is, as I pointed out here, where I gave you some examples of applications already running on Hyperledger, and we can handle pretty much any application you can imagine at this point in time.
Awesome. And then, John, there's additional comments by Max in the Ask a Question section, so check that out. Okay, the next question. Does Bitcoin have a similar number of actors as blockchain?
Similar number of actors? I didn't quite understand that.
Yeah, I think, Rakesh, if you don't mind clarifying that in the comments section, in the Ask a Question section as well, that would be great. Okay. Posting the link. Let me see the most upvoted question. Does it cost money to use Hyperledger Fabric, or just the cost of hosting the platform?
It doesn't even cost 1 cent. It's totally free because it's open source. You just download it, use it, and you will have a good time.
Awesome. And I think we'll do one last question here. And then after the session, Lennart can go ahead and answer them in the comment section. So the last question, what's the relationship between blockchain and Bitcoin mining?
Yes, yes, indeed. Bitcoin mining is part of the leftmost fork of blockchain that I mentioned. And it has Bitcoin mining is something that belongs to, does not belong to the Hyperledger world. And if you want to know more about it, there are lots of information about it, but it's not something that we, I think, need to take up here because we may spend a lot of time talking about it.
Awesome. So thank you everyone for all of your questions. The additional questions, Lennart will be answering after the session, but thank you very much for everyone who joined us today. You have access to all of, you'll have access to the slides. I'll send that to everyone who registered, so thank you. And this recording will be available after we close out the session. We hope to see you next Tuesday for part 2 of this series, and thank you so much to our speaker, Lennart.
Thanks.
Have a nice day, everyone. Bye-bye.